Good morning, everybody. Good morning. Yeah, slowly, but we'll be getting there. Okay, cool. Hi, everyone. So let's see where we can take this. So Kubernetes. Who's already using Kubernetes? Okay. Who's using it in production? Okay, that's 50% or so of those using it. Recently, I saw this tweet and I really liked it, that whatever the question is, Kubernetes is the answer. Because that seems to be where we're headed right now. That doesn't really matter what you want to do, Kubernetes is the answer. And well, for logging and monitoring, this adds some interesting new challenges and ideas. And I basically want to dive into those. So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. Who's using any of our products already? Okay, good. Who is using them with Kubernetes already? Okay, how is it working out? Good? Okay, good. Why are you here? Okay, let's see. Maybe I can show you something new, or maybe you can show me something new. We'll see. I have like my demo wired together, and then we can discuss at the end of how this is working for you, or what is not working, or what we should be adding. So yeah, I mostly travel around to show what we have and the fun stuff that is out there. And imagine your boss comes in and he looks like this and he's about to shout at you because something is not working. And this is my boss, this is Shai. He initially wrote Elasticsearch, but he's our CEO now. And he doesn't always look that angry, but if you break stuff, maybe he looks that angry. So imagine that he's coming in and says like, the app is broken. And obviously it's deployed in Kubernetes and you have no idea what is in there or what has been deployed and what you're supposed to do. So since he doesn't look happy, you will try to take a look at that. So let's see what we have here. Let's say first off, so I have this running locally in Minikube and we have Kubernetes Demo, and we'll try to open it, and indeed, well, there is a 500, and now you can understand why Shai is shouting at you and tells you everything is broken. Unfortunately, you have no idea what this app is about. So you need to kind of figure out what even is there and what you have there. So this is Kibana. If you have never seen Kibana, well, menu on the left now, and it's blue. In the next major version, by the way, the menu will kind of disappear and be like, there will just be a button in the top right corner, but that's another story. So you're at Kibana, and you don't really know the app. So you don't really know where to start or what you even have to look at. So this is version 6.5, which was released like 3 weeks ago or so. And this added some nice things to make that debugging and starting easier. So there is this infrastructure thing here. Has anybody used that already or seen that infrastructure UI? Anybody? Okay, so it was added in 6.5, so it's pretty new. You can see here you have 3 things that it supports. First off, hosts. And those hosts, if you, for example, have cloud instances like EC2, it could show you like how many cloud infrastructure or instances do you have, in which availability zones are they, in which regions, across cloud providers, etc. Since this is running on my little laptop here, and well, it's Minikube, there's only one host that is running, but it could show you, for example, okay, this is the CPU usage, or this is the memory usage of Minikube. I think I've given Minikube 4 gigs of memory, or 2 or something like that, and it's using 80% of that already. But, well, this is not that interesting, but you can see we have more buttons here. So we do support Docker, for example, and you see these are all my Docker containers that I have running here. The nice thing is this finally kind of scales. So if you have 100 or 200 containers running, you will still be able to kind of see, okay, CPU-wise, all of them seem to be doing okay. Or you could say like, let's see, memory-wise, this is what we have. You can also group them, but for Docker, we don't really have much good stuff to group here. For example, I don't have like, this is again like more the cloud infrastructure, but let's head over to the Kubernetes view. So, well, it has 28 images or containers running in Kubernetes, but here you could start grouping a bit more. For example, we could say like, show me the nodes. How many nodes will come out of that? 1 again, because it's Minikube. You won't see much there. But if you have a proper production setup, you would see like which hosts are even involved in that. But we can break up by namespaces, and you can see we have 3 containers in the default namespace running. And then we have 25 in the kube system running. And you can see we have file beat here, we have etcd, core DNS, those are not the ones I want. We have APM, we have a file beat setup. So you get an idea what you even have in your infrastructure. And then you can start clicking around and see like, okay, memory-wise, looks like they're all pretty okay because they don't really use much memory. What about inbound traffic? Okay, but 3 kilobytes, that's also not very much because, well, it's just the scale is very low. Outbound traffic also looks pretty decent. I'm not sure. Let's see. Maybe we can see some more details of one of them here. Let's take the MySQL container here. And if you click on that, you can see view logs, but we'll get to the logs afterwards. Let's stick to the metrics for now. Let's head over to view metrics. And here you can, for example, see like for this specific container in this time frame, but you could keep that auto-refreshing and just update continuously. You see how you're doing memory-wise and CPU-wise and network traffic-wise. So this makes the initial debugging easier, but it's not a resource problem, so this is just like how to get started here. So where am I getting all of this information from? How can I fill all these charts? Because, well, I can show you pretty pictures, but that's not really helping you how to set that up. How do I collect the information to get into my Kibana? Sorry? No, not Fluentd. Yes, exactly. We have metric beat running. So this is my general setup, what we have running here. So we have our Python application running, but doesn't really matter that much. I don't want to dive into the application too much. And then we have our beats running here to collect the information. For example, metric beat. At first, we have a config map. So this is the configuration this is using. So for example, you can see we are collecting the system module. Every 10 seconds, we are collecting stuff like CPU load, memory, etc., including the top processes that are running here. We're also, every minute, we're also collecting some file system information, but we're dropping some events that we don't need so much. For example, system, C group, proc, those we don't need. We also collect the Docker information. So you can see here, this is whatever container is using on a resource level, and we collect that every 10 seconds. The same thing for Kubernetes, where we collect here the node, the system, the pod, the container, the volume. So this is how we could group that, and how we could also see this is what we're using network-wise and memory-wise and CPU-wise for every container, because we're collecting those here. So this is basically the base configuration that we're using. And then, how do you run that in Kubernetes? How do you make sure you have something running in Kubernetes to collect that information? Sorry? Yes, there is a pod, but the specific thing what I'm running that here is, and you have that here, we're running a daemon set. So we basically make sure there is one instance on every host that we have. In my system, since I only have Minikube and one instance, there is only one exact instance of that. And this is running in the kube system namespace, by the way. So we put it in the kube system namespace, all the daemon sets that we have for the beats, and then your application is running in the default namespace, or whatever the namespace is that you're using for your application. And you can also see some other things that might be interesting is like, we're using the Docker socket to get these informations. How do I get the Docker socket information in a daemon set? Well, I need to mount that into the right container. So for example, here you can see, okay, we're starting metric beat with this configuration, that the config map that we have shown up before. But what is more relevant down here is we have a specific user that this is running, we have some limits, but then this is what we need to mount. So for example, we have a mount path for the Docker socket. So you need to mount the Docker socket into that container, the daemon set. So you're actually, so metric beat is actually able to use that information. Why am I mounting, for example, the host file system or the C groups in here as well? Because we wanted to show some statistics about the file system usage, and well, we need to collect that somewhere. So these are all things that I mount into my container so that I can actually access those. And you can see these are all the things that you need to mount into that one. And well, we make it read all, don't need execute rights, but we need to read at least from that, and that's what we have there. We also have another configuration map where we have like the cube state metrics. We can collect those as well, and we have a separate container to collect those every 10 seconds, the cube state metrics. And then we take all of that information and put it into Elasticsearch. And besides these new fancy dashboards that I've just shown you, we also have the classical dashboard, so you can see what you actually have there. So for example, here, what are we looking for now? Metric bit, and let's stick to system. So we have a system overview that probably makes sense to see what is going on. It tells us, okay, we have one host running. That's okay. That's my Minikube. You can see the overall CPU usage, memory usage, and disk usage in Minikube, since we only have that single host. And you can also see the heat map of the CPU usage. If you had more running, you would see all your hosts here. You could also dive into that one host, so for example Minikube here, because well you only have one, and then you can see all the statistics of that specific one. So for example, you can see in total I have given my container probably 2 gigs of memory, or my Minikube 2 gigs of memory, and I'm using 1.6 or so of those. And you can see overall how you're doing resource-wise, which looks pretty okay. And you can see CPU usage, memory usage, etc. What would you do if you wanted to see, for example, the memory usage per pod? Probably you would need to build your own visualization, right? Let's try to build our own visualization for that. Any suggestions, what would be, since we have some users here already, what would be a good visualization for showing the memory usage per pod? Any favorite visualizations? Line, nah, line is boring. I'll use the visual builder. Everybody familiar with the visual builder? It's kind of a bit of a newer visualization, but it is a bit more powerful. So the first thing you need to make sure is that you're actually, we want to get metrics, because right now this is showing you files. Let's make this metric beat. And what does it show you right now? The number of documents it has collected every 10 seconds. So every 10 seconds we're collecting 358 documents, but that's not what we want. We want to see the memory per pod, for example. So let's say I want to have the sum, and then that field appears here, and then you need to know what memory statistics you have. So let's say, no, not Kibana, Kubernetes is what I want. Kubernetes container memory usage bytes. That sounds promising. You can see memory usage is pretty flat. The one thing that kind of annoys me here is that that number is very hard to read. How much memory are we actually using here? Nobody really knows. So what you can do is, by the way, in options here, you can say, this is not a number, but these are bytes. And if you switch that over to bytes, you can see, we're using 800 megabytes here. Okay, that makes more sense. But this is a total. And then we want to break that up on the per pod level. So then you can say group by, and then we have specific terms here. And the terms will be something like Kubernetes dot pod dot, probably there's a name. Yeah, that sounds promising. And then you can see which pod is using how much memory in your setup. And well, right now we have the top 10. We could say we want the top 12, and we want to sort them by the amount of memory. And suddenly it's scaled slightly out. But you can then see here, for example, this one here, the MySQL one, is using so much memory. The one thing, now I have clicked on one to select that. One thing that kind of confused me for quite a long time is, how do you get back all of them now? Since you have clicked on one and we have filtered down on that one, how do you get back everything? Yes, you could refresh the page, that's what I have done for some time, but actually the right way to get it back is click on the selection again, and then you will see all of them. But it's not the most intuitive UI pattern, or at least it confused me for quite some time that, well, now all of them are gone. Okay, so we can see resource-wise it looks kind of okay. We're not running out of CPU, we're not running out of memory, network seems fine. So we probably need something else. Where could we head next? Yes, let's see the logs. What are we using to collect the logs? FileBeat. Okay. So, any guesses how we configure FileBeat to collect stuff? The same, yeah. Let's see. We have a daemon set for FileBeat. And here we have a configuration. This configuration is slightly different. Don't steal my passwords. Because, well, as a backup, I'm pushing everything online, so we could always continue online. What is interesting here is we didn't really configure much. We say FileBeat autodiscover, and then we say hints enabled true. Anybody knows why we're doing that and what are we even doing here? We autodiscover, interesting. We didn't hardcode anything. Why are we doing this? Or what is kind of the classical way with FileBeat to do something? The classical way would be to either say, well, this is the file path where you collect something, but that's kind of difficult in Kubernetes because you never know where is what file and what are you actually collecting. And yes, you could mount that out of every container into the FileBeat container to collect it, but it's very static and very hardwired together. So we don't really want to do that. So what are we doing here? So here we have hints enabled true. What we're basically doing is we will use annotations in Kubernetes to actually tell it, the FileBeat, what kind of data we have here. So if you look into, if we look into our application and that is deployed here, it has a label that's not so interesting, but it has these annotations. And these annotations are actually what we're using here. So basically we're configuring the log collection on the application or on every container that we want to collect. We're configuring how to collect the data or what data to collect there. So here you can see, obviously this is running Nginx. So we are enabling the Nginx module to collect Nginx information. We want to get access and error logs. We also, well, we collect that every 10 seconds and something or that information is running on port 8080. So we are not putting that into the daemon set and configuring everything that we have in our system in the daemon set, but this is actually my application. So this is the deployment of the app that I'm using. You can see here, this is my demo Nginx image, and we have here my demo app that is running behind that. We're not explicitly hardcoding it anywhere else, but we are adding that configuration right with the deployment itself. Okay, makes sense so far? So let's see. By the way, how are we then getting the logs? Where are the logs being put? Yeah, you can see here, well, they're going by default to standard out and standard error, so we don't need to collect any files, but we will just tail standard out and standard error and get all the data from there. So let's see what we have. You want to see a dashboard first, or we want to dive into the raw data? Let's look at the raw data. Okay, so you can see here we have FileBeat, but that might be a bit too much because in the last 15 minutes, 7,000 hits, that was not what we had. We maybe had like 1 or 2 errors here. Let's create a few new ones, but this is not what we have collected here. So we will need to collect or get down to the right data. Let's see, is it input type? Is Docker? No, this is not what I wanted. This is if you have multiple input types, this can be helpful for that. But what you want is there is there a type? Let me think, where did I put this, or which is the right field that you want? No, this is not what I want. This is also not what I want. Okay, let's take the stupid approach. We don't know what we're looking for, so we'll just search for Nginx over everything. That looks better. We only have 32 events now. Here we had more. This looks promising. And then you can see, okay, what do we have? We have file set module, so this is probably the filter we want to have. if you can't remember, just start typing whatever you remember, and it will probably take you to a subset of what you want. So file set module is, let's put the filter on that. File set.module is Nginx. Now we have a hard filter on that. The full text filter is not really relevant anymore. So this configuration here collected only 2 events or hits in the last 15 minutes. If we say we want to have the last 12 hours, I only started that a few hours ago, you can see Nginx collected like, okay, 15 hits over that time. Let's see what we actually have in here. So you can see, first off, here you can see all the metadata that we have enriched. So this is the Kubernetes metadata that we have added. So we're adding that information to every single event that you can afterwards filter down on that. So you can see we have the container name, we have something like labels, we have the pod template, namespace, etc. So you can filter down on all of those or search for them. And how are we enriching that? Basically, the file bit is querying the Kubernetes API and then caches that information from the Kubernetes API because it knows the pod, and then it can just match the pod that you are running with the API information. It doesn't query the API every single time, but it caches that information for some time. We have the same information for other things as well. So we could do that for Docker. We can also do it for cloud providers. And we can do it for hosts. So for hosts, it would be like the operating system or the version of your operating system. So then it would say Ubuntu 18.04 or whatever you have. And then you can see, here you can see the other events that you have in here. So you can see, okay, Chrome, this is my browser, was doing a request. Unfortunately, the response code was a 500. That doesn't look too good. Nginx access response code. That actually looks promising. Let's see if we only had those error response codes. How could I graph out which response codes my entire system has been serving over the last 12 hours, for example? Well, before I forget, I'll copy that. Let's do another visualization. So here, pie chart. I mean, this time I don't have a strong preference. Let's go for the pie chart. And well, we want to have data out of FileBeat, and I want to split up. You can see in total we have these 7,600 events in the last 15 minutes. Let's actually broaden it out to 12 hours. Then you can split the slices, and then you can say, I want to have a term segregation, so I want to break that up on a specific term, and that was called Nginx access response code. Let's say we want to have the top 10 access response codes. And if you run that, it will show you, okay, mostly 60% or 9, not that many requests since it's just me, were 500s. But we also had a 3 or 4, and we also managed to have 200s. I'm curious what people did to get a 200 out of that. So, Nginx access, was it response code? Response code is, let's say, we want to filter only down on the 200s now. Especially if you have lots of data, like just randomly searching around is not going to help you, so you want to filter a bit more. So let's filter down on the 200s, and then you can see, oh, we had 4 200s. And if you open those up, it tells you, okay, we had a get, we had a 200, and we were going for the about page. Okay. Let's see if our application has an about page. Okay, that looks decent. This is, by the way, the architecture that we have. So we have a Python application and an Nginx reverse proxy in front of it that's proxying it through. They are backed by MySQL. And then we have the load balancer for our demo running here in front, and then we have various beats running as daemon sets. So this is the overall architecture that we have. We could submit a question. So let's say we have foo bar, but when I submit that, it runs into an error again. It's kind of stupid. What is going on here? What other beat could I use to figure out what is going on in my system? Any guesses? Or, by the way, I wanted to show you some other dashboards. Let's see, dashboard. One of the dashboards that we have is Nginx. If it loads. We have a file bit nginx overview. You don't see much on the map because everything is against localhost, and localhost is very hard to draw on a map. So you have no idea. But you can see here, these were the response codes that you have, which URLs were hit. And you could also see nginx access and error logs. So here you can see how many times was the page accessed. It didn't have any nginx errors itself, but we just had errors back here. But at least you see these were the URLs we hit and the response codes and how much traffic was sent. We still need something else to figure out what is the problem here. What do you do if you're desperate? Yes, I'm telling you there is not going to be much in the logs. We could cheat and head over to Minikube and say we want to have the pods, we want to have the... No, this is the wrong... where did I want to go? I wanted to see my nodes, Minikube. We want to have our Kubernetes Demo. Let's pick the one instance we have here. Let's look at the logs. It's not going to help you much, I'm afraid. We need something else. Where do you go when you're desperate? Yeah, okay. I meant Wireshark. Like that's normally also a good one, right? When people have Wireshark open on their computer, you know they have no clue what is going on anymore, because you just look at random packets and you want to figure out what is going on. In our stack, what do we have for Wireshark? What do we have which is kind of like taking over the role of Wireshark in the Elastic Stack? There's PacketBeat, yes. So PacketBeat is, let's quickly look at PacketBeat, at the daemon set of PacketBeat. So basically what I'm looking here at is we have DNS, we have HTTP on port 8080, and we have MySQL. And well, we add the Docker, the Kubernetes metadata, so all should be well. And by the way, this is the important setting. To sniff the network traffic of all the containers, you need to set that capability, the net admin. If you don't set that, you won't get any traffic. This is, you maybe have run into this and have been fighting that, but that is kind of sometimes a problem. Okay, let's see. Let's start with the dashboards. So we have PacketBeat, and we have an overview. Once again, drawing it out on the map is hard because localhost, but you can see here in the last 12 hours, we had our fair share of HTTP requests and we had some MySQL queries. That looks good. You can also see over time, these were the height is basically how many requests did you have, and the color, how long did they take. You can see response percentiles, which are okay. I mean, 1.5 seconds on localhost is more or less okay. You can see errors and okays. Also, let's make okay like red-ish, kind of like makes more sense. And then you can see which errors did you have. Mostly DNS. We could now try to dive into the DNS errors, but the DNS errors are not what we're looking for. We had very few MySQL and very few HTTP errors. You can also see the latency histogram, and you can see how this developed over time. So, what could be going on here? Let's see. Let's look at web transactions. Web transactions are basically everything that you have been collecting here. So everything on port 8080, like 25,000 requests over time. You can see which URLs were mostly hit and what were the response codes. You can also see like here, metrics, server status, health set, those were all collected. By the way, these are all automated. This is all automated traffic. I'm mostly interested in stuff like this, the base URL, the about, the submit, because this is my own application. Could I exclude those things in PacketBeat automatically? Yes, you can. I have not configured it, but this is how this would look. So you could just drop an event and say when the path, since it's HTTP, contains either health or is equal to metrics, then just drop the packet. So you could get rid of these automated pings because they normally just fill up your logs and they don't show you much. But what we want to actually dive into is the MySQL performance here. And you can see here, okay, we have some queries. Those look reasonable. We have some selects, shows, sets, inserts. So our application seems to be alive because it's doing some queries. You can also see response percentiles. You can see what has been happening and the sum of throughput. You can also see which queries were ran. Okay, this is just a statistics query, but you can see our application is a Django application, or at least it looks like a Django application, and it has been running a couple of times, but somehow it has not been getting the right results. Any guesses where we could find out what has been happening? Let's see. Let's head over to PacketBeat. And let's look at the raw events. So, what is it called? I think it's called mod. Is it not called module? I always forget how to dive into the right area. This is not what I wanted. Go away. So what we want is, it's not the method. No. Let's go for the method select. Let's see if we have any packets with select. And then you suddenly see, oh, we were running a query. This is the query that ran. And this is the actual problem. Somebody, probably me, forgot to create the right database. And that's why our application has been failing, because, well, when the database doesn't exist and you don't automatically create it with your application, then your queries will error out. So you could have also searched for type MySQL and status error, and then you would have found that. But once again, when you're desperate and you don't know where to go, you can basically head to Wireshark or PacketBeat to figure out what is happening here. Since we're running slightly short on time, I will not try to fix the application, but there's one more thing I wanted to include. Let me switch to another demo that is also on the internet, and that includes something else, which is APM. What is APM again? What does it stand for? Application Performance Monitoring, or basically tracing. So we have multiple applications running here. Let's say we head over to the React application because, well, React is fun. By the way, you could see here in the application, okay, I should not have done that. Please. Okay, so you can see we do support quite a few languages like Java, JavaScript for front end, Node, Python, Ruby, Go, .NET is the next one. This is basically an agent that you add to your application, and it will then just trace all the calls in your application. So for example, in my Python application, even though I cannot show you because my application is broken, what you basically do here is you add a dependency, and then you say this is the service name, and this is where to send the traces. And basically you have, in your requirements, you have one more dependency, which is Elastic APM, to collect that. If you use Java, what is the right way to collect traces in Java, for example? You can just add at runtime -java agent and add that to runtime to see what this is doing. So the nice thing here is, now let's go for React. This is showing you, in the last 24 hours, what was the response time of your services? You can see this was kind of high. And then you can see transactions per minute, which these look okay. But then you can also see which pages do you have? How long did they take? Okay, you see this 95th percentile, 1.8 seconds. And 11 transactions per minute is kind of not so great. So you could look into that one specifically. And this integrates into Kubernetes and everything else as well. So you can see just this URL had these response times and was hit that many times. You can see we have selected this one here, or we could also select, for example, the slowest one, where we have one transaction. And then down here, you can see where this call was going. So once your application is working again, you can then follow it along. And you can see we have our React frontend, we have our Node application which is doing something, and then we have our Spring backend that is running. And then, for example, you could see here our Spring backend here has get owners, and you can see, okay, this is where this is running, for example. You can see the path, the sockets, all the headers. You can get that information. You can also see like the system information where this is running. You can see which services are involved. You could also enrich that with Kubernetes at some point. For example, the Java version, whatever. Do we have any custom tags here? No. And then, for example, you could see what are all those SQL queries that you're doing, or the select queries. And then you can see, okay, these are actually the select queries. And you can see, okay, this was a select that took 4 milliseconds, and that was 0.1% of the overall time of your application. This is very handy to debug. And you see, it's not that these calls are slow independently. It's just you do a lot of single select statements, which you probably should not do, because this is not a very good pattern if you see your application doing that many requests. So this is how you could debug that. So once you have fixed your application, you can also figure out when somebody complains and says like, your application is slow, which is normally very hard to figure out. This is why something is slow. And that is kind of the APM side. And that integrates nicely with everything else. So for example, just to show you, if my application had been working, this would be the configuration to add the daemon set for APM, the APM server, and then everything could just send their information there. And well, we would add the Kubernetes metadata here, so we would have all the right information, you know, this part of the application is in this pod, and then you could also correlate that with resource usage, etc. So you can go pretty wild there. Okay, since we're running low on time, what did I want to say? Yes. Okay. So kind of the entire point of this talk, or not the entire point, but part of what we often try to do is that you want to go from like having one little island to do this and one little island to do that, to have one tool that is kind of like more the global map to show you everything that you're doing. That could be the logs, that could be the system usage, that could be network data. It could also include like pinging the system or security data. We do those as well. And you can integrate all of that with Kubernetes. That's pretty much what I wanted to get across here. If you are more interested in kind of like what we're doing internally with Docker images, what we built and how you could run or will be able to run Elasticsearch easier on Kubernetes yourself in the future, I have another talk tomorrow, I think around lunchtime or so. That's more the insight or the meta talk. This was more the monitoring talk for the external systems. And with that, do we have any questions, complaints, discussions? Yes, please. Do we have a microphone or? Yep, 1 second, please. By the way, before you run off, I have a couple of stickers here. If you want to have stickers, grab stickers afterwards.
Thank you. My name is Henri.
Hi.
The question is the next. Is there a way to join together all that stuff in APM and like cloud services like RDS, Elasticsearch in Amazon, something like this? So probably if we could expose our internal gateway for those metadata, I don't know, maybe you can...
So, sorry. If you talk about, for example, RDS, we have something now we call function beat, which is basically running as a serverless thing on AWS that could get the CloudWatch events. So it could integrate into that. It is not really explicitly in APM yet, though probably APM will integrate with serverless in the future as well at some point. But if you want to, for example, the CloudWatch metrics and correlate those with whatever else you have in your system, you can do that with something called Function Beat, which also came out in 6.5 for the first time. So that's pretty new. Was it your question, or did you mean something else?
Yeah, it was my question, because the problem was I have like logs in API Gateway. I can see what comes into my applications. I can go to, for now, I use Sumo Logic. I can get all my logs, what are in my applications. Then I have to go to RDS and take a look at what's going on there. But I would prefer to have all this stuff together and in the way like you've just shown us, or in the way like Zipkin shows.
Yes, that's what we're trying to do. I mean, with our APM has a very strong overlap with Zipkin already. But this is Function Beat. This is what Function Beat is doing. You can see it runs as a Lambda, and it basically takes the CloudWatch logs, SQS, and potentially other services in the future and just stores that into Elasticsearch as well. So that's, if you have like third-party services, this is where we try to do this. Also, if you have other services, Logstash is out there, and Logstash has a lot of plugins into other systems. So if you want to get like specific things from, I don't know, queues, like statistics or whatever, then Logstash can do that as well. Yeah, sure. The general idea is always we want to kind of like get everything into our stack and then have like one place where you can see everything that's going on. Thank you. By the way, before you run off, I always try to take a picture with you, you know. So
yeah,
since
one more question, sorry.
Wait.
Oh, okay.
This is important. My colleagues don't know where I am. Yeah, wave, thank you. Oh, wait. Very good. No, my colleagues don't know where I am, so I need to prove.
Okay.
Sorry.
You mount host file system into containers. Mm-hmm. Is it secure?
Yeah, that's the trade-off. I mean, you have seen with the permissions we set, we could discuss about the metric beat daemon set. Where do we have the mount? Yeah, I mean, the thing is, if you need access, like once you have access to the Docker socket, you have access to the Docker socket, which is not very fine-grained, but this is kind of the trade-off. What we can do, if you don't want to give it access to the Docker daemon, you will not be get the Docker information, but we do get the C group information from proc. You can use that as well. Then you don't need to mount the Docker daemon. The downside is it doesn't have the labels or anything. No, this is not what I want. Metric beat. Sorry, I'm wrong instance. This is the one I want. Metric beat. And then there is a containers overview. And you can see this here is just the proc information. Then you don't need to mount the Docker daemon or socket. Because yeah, once you have access to that, you have access to it and you can do bad things as well. This is just using the proc information, but you can see it has a name, but it doesn't get like Docker labels or anything because, well, it doesn't get that metadata. That's kind of the trade-off. But yeah, I don't think there is a final answer to that. Are you okay with like querying Kubernetes to get that information? Because that's only through the API. That's probably...
I think it's can be collected on the host file system, not into a container.
Yes, you can also collect it on the host file system, but then you will either need to mount the host file system into the container or install the beat on the host.
I think beat on the host.
Yeah, I mean, that's totally possible. A lot of people want to have everything in containers, so that's why we generally support this sidecar approach that you put it into a container, but you can totally install it on the host and work from there, yes. That's
okay,
whatever makes sense for you. More questions, or are we out of time? Well, if you have more questions, just come to me afterwards. I'm happy to answer whatever you have. Doesn't have to be about containers, can be about our stack in general or anything. Thanks a lot.